All right, here we go. We're going to go through this final exam review. So make sure if you don't know something that you just pause the video and rewind if you need to. But let's get right into it. So question number 1, f of x is this absolute value equation. We want a function g that represents a reflection in the x-axis and a translation up to. So remember, if we're reflecting in the x-axis, if we have a point up here, it's reflecting down here, then the x does not change, just the y value, so we're multiplying the whole function by negative. So we're going to take basically negative times f of x, and then we're going to translate it up to. So what that would look like here is going to be g of x is going to be negative absolute value 4x minus 1 plus, not plus 4, minus 4, because we multiplied it by a negative, right? And then we're going to add 2 to that. And so our function g of x is going to be negative absolute value of 4x minus 1 minus 2. And that's going to be our function. Question number 2, solve the inequality. 2 times the absolute value of 4x minus 1. Let's make that there. That's probably okay. 2 times the absolute value of x minus 4 minus 1 is less than or equal to 15. So we want to get the absolute value by itself. So we're going to add 1 to both sides. We're going to divide by 2 after we do that. So we'll end up with the absolute value of x minus 4 is less than or equal to 8, because we get 16 then divide by 2. So let's see, I'll come over here and do that. So we got absolute value of x minus 4 is less than or equal to 8. Remember, since this is less than, this is going to be an and inequality. And so since it's an and inequality, they'll be kind of connected at the end. So we're going to split up to 2 inequalities for this. We have x minus 4 is less than or equal to 8. And we have x minus 4 is greater than or equal to negative 8. And so we're just going to add 4 to both sides. So we get x is less than or equal to 12. And x is greater than or equal to negative 4. And so that's our solution. So we're going to have x is going to be in between negative 4 and 12. And that's our solution. All right, number 3. Evaluate the piecewise function when x is negative 1 and x equals 3. And then we want to find f of negative 1 plus f of negative 3. All right, so when x is negative 1, we want to be here because we are equal to negative 1. So f of negative 1 is going to be 3 times negative 1 squared plus 5. Negative 1 squared is 1, times 3 is 3, plus 5 is going to be 8. And then when x is 3, we're going to be here. So we have f of 3 is going to be 2 times 3 plus 2. So that's 6 plus 2, which is 8. So nice. All right, so now we want to find f of negative 1, which is going to be 8, plus f of, well, I should say positive 3, shouldn't it? Plus 8, and that would be 16. All right, so a little bit of a typo there. That's positive 3. It should be positive 3 there. And here. All right, cool. So our final answer is going to be 16. All right, now number 4, we want an equation of the parabola. So it just says an equation, so it doesn't have to be a standard form necessarily. But we know that we have the point 5, negative 1, and a vertex of 2, 8. So if you remember your vertex form, you got f of x is equal to a times x minus h squared plus k. And so we know our vertex, we got h and k. So we have f of x is equal to a times x minus 2 squared plus 8. And then we'll go ahead and plug in the point 5, negative 1 for x and f of x. We got negative 1 is equal to a times 5 minus 2 squared plus 8. So we got negative 1 equals a times 3 squared plus 8. I'm going to move the 8 over there by subtracting it. So I have negative 9 equals 9a. So that tells me a is negative 1. So there's my value of a. So my function is going to be negative 1, or just negative x minus 2 squared plus 8. So there's my function. If they asked for it in standard form, I would need to distribute that x minus 2 out, multiply by negative, and then add 8, but we don't have to do that here because it just says an equation. Okay, number 5. What is the average rate of change for that equation, or that function, over the interval from 0 to 2? All right, so remember your average rate of change formula is y2 minus y1 over x2 minus x1. We don't have all of those. We have the x2 and the x1, right? 0 is going to be x1, 2 is going to be x2. So we have those. So we have 2 minus 0 in the denominator. But to get y2 and y1, we're going to need to plug that in. So if we plug in 0, we have 4 times 0 minus 2 times 0 plus 8. So that's going to be 4 times negative 2 times 8. So that's going to be negative 8 times 8, which is negative 64. So that's our x, or that's our y1. y1. So that's minus negative 64. And then we want y2. So we're going to plug in 2. So we have 4 times, we got 2 minus 2. And then 2 plus 8. So we got 4 times 0 times 10, which is just going to be 0. So there we go. Let me move these out of the way here. All right, so we've got negative 64, which is positive 64 over 2, which is going to be 32. So the average rate of change from 0 to 2 is going to be 32. All right, good deal. Move those back there. Okay. Solutions. 2, 4x squared minus 4 equals 12. Well, I can add 4 to both sides. So I have 4x squared equals 16. Divide by 4, I got x squared equals 4. Take the square root from there. I got x equals plus or minus 2. Simple enough. Then number 7 is solve x squared minus 4x equals 12. So now this is different because I got a 4x. Here it was just a 4. So I have to make sure that I move everything to the same side now. So I'll have x squared minus 4x minus 12 is equal to 0. Since I have an x squared and an x, I need these to be equal to 0. And then I'm going to try and factor here. So I got x and x. Factors at negative 12. That'll be negative 6, positive 2. That'll give me negative 4 and negative 12. So I've got x equals 6, x equals negative 2, and there are my solutions. All right, moving right along. Simplify the expression. So now we're going to use the distributive property. Let me rewrite this over here. Negative 3 minus 3i, negative 6 plus 7i. So I'm going to distribute this here. So I've got 18 minus 21i. Then I've got plus 18i minus 21i squared. Okay, so remember, I squared, that's just negative 1. So this is really a plus 21. So 18 plus 21, let's see, that'll be 39. Negative 21 plus 18, that is negative 3i. So there is my simplified answer. All right, simplify the expression 2 over 3 minus I. So remember, when we have I in the denominator, we want to get it out of the denominator. So we're going to multiply by the conjugate, the complex conjugate, which is 3 plus I. So now we just distribute up top. So we got 2 times 3, which is 6. 2 times I is 2i. In the denominator, because we're multiplying by the conjugate, we just have to multiply the first two and the last two together. So it's going to be 9 minus I squared. And remember, we just looked at I squared is -1. So this is basically 9 plus 1. So it's going to be 6 plus 2I over 10. And I can still simplify that. I can divide everything by 2. So it's going to be 3 plus I over 5. And there's my simplified expression. All right, so now I want to get the vertex of that standard form equation. So remember, to get the vertex, we've got h. It's going to be negative b divided by 2a. So in this case, we've got negative 12 over 2 times 1. So that's going to be negative 12 over 2, which is negative 6. Then k, we want to plug that in. So we've got negative 6 squared plus 12 times negative 6 plus 4. That's going to be 36 minus 72 plus 4. So negative 36 plus 4, which is negative 32. So what's the vertex? That's going to be negative 6, negative 32. All right. Solve the system using any method. All right, so I got a quadratic and a linear, but they're both equal to y. So I'm just going to set these two equal to each other. So I got 2x squared minus 6x plus 3 is equal to negative 4x minus 2. I will add these over to the other side. So I got 2x squared minus 2x plus 5 equals 0. All right, so we can try factoring if we wanted to. I'm not sure if it's going to work or not. We're going to have 2x and x. I know for my factors of 5, I have to have 5 and 1. I don't think that's going to work. 5 and 1. Because if we do 5 here, 1 here, we could just get 3. All right, so we're not going to factor. We're going to try and do quadratic formula, I guess. All right, so we got x is equal to negative b, so negative 2 plus or minus the square root of negative 2 squared minus 4 times 2 times 5, all divided by 2 times 2. All right, so we got 2 plus or minus the square root of 4 minus 40. Yep, so that's not going to factor. Divided by 4. All right, so keep going. We got 2 plus or minus. That's going to be the square root of negative 36 over 4, so that's cool. We got 2 plus or minus 6i over 4. There you go. So what are our solutions? Really, these are not going to intersect because we have an imaginary solution. But we'll finish out the x's, I guess. This is going to be 2 plus, well, we can divide everything by 2. So we got 1 plus or minus 3i over 2. So because this is an imaginary solution, these will not intersect. So imaginary solution, no intersection. So pretty much that just means we have, like, in this case, the parabola is, let's just say it's like up here, and the linear function is down here. So they're never going to intersect because the linear function is below the quadratic function. All right, so number 12. Let's take a look at number 12 here. So we've got f of x and g of x. They want us to find f of g of x, and they want us to find f minus g of 2. So two things. All right, so f of g of x. F of g. So we're going to take f of x, which is 4x minus 1. We're going to take g of x and put it into it. So we have 4. Instead of x, we're going to put g of x, which is 2x squared plus 3 minus 1. So that's going to be 8x squared plus 12 minus 1. So that's going to be 8x squared plus 11. That is f of g of x. And then f minus g of 2. A bunch of different ways you could do that. We could do f of 2 minus g of 2. I think I might just do that. So f of 2 is going to be 4 times 2 minus 1 minus g of 2 is going to be, put this in brackets, 2 times 2 squared plus 3. So that's 8 minus 1, which is 7, minus 2 squared is 4 times 2 is 8, and then plus 3 is 11. So we got 7 minus 11, which is going to be negative 4. All right. Number 13. Divide the polynomial by x minus 1 and give the remainder. So this is going to be synthetic division we can do here. So we'll set up a polynomial. We got 4x to the third, negative 1x squared, negative 5x, negative 4. Or dividing it by x minus 1, so we'll put a positive 1 out there. Alright, so we're dropping the 4, multiplying by 1, we get 4, minus 1 is 3, 3, that's negative 2, so negative 2, negative 6. That's our remainder. So we could rewrite the function. We're going to have 4x squared plus 3x minus 2 minus 6 over x minus 1. But the remainder is just going to be negative 6. All right, now we want to divide 35x squared minus 34x minus 22 by 7x plus 3 and give the remainder. All right, so we're going to set this up with long division here. So remember, long division, we're going to take the first term, which is 35x squared, and we're going to divide it by the first term out here. So that's 35x squared divided by 7x, and that's going to give us 5x. So that's going up top. Then we'll multiply by everything out here. So we got 35x squared plus 15x. Well, we'll bring down 22 later. So we're going to change the sign of everything. Those will cancel. That'll give us negative 49x. We'll bring down the 22 and do the same thing. So we got negative 49x over 7x, which is just going to be negative 7. So minus 7. And then we'll multiply out there again, so negative 49x. And then minus 21. Change the signs. Those cancel. And we will get negative 1. And that's going to be our remainder. So we'll have minus 1 over 7x plus 3. So dividing that is going to be giving us that. Now we want to factor the polynomial here. All right, so we're going to factor out a negative 3x first. So negative 3x. All right, so that's going to give us x squared minus 16x and then 189. All right, negative 189. Let's throw that in the calculator here. 189 divided by 3. That's going to be 63, so minus 63. All right, so then we can still factor that part. So that's going to be negative 3x. Factor the quadratic part, we got x, we got x. Factors of 63 that add to negative 16. I think that's going to be, let's see, 63 divided by 9 is 7. Oh, but that's going to be positive and positive, isn't it? Yeah. So let's see. Yes, we can do plus 9 and plus 7. So that'll work. And then we have factored it. Cool. All right, solutions to the equation here. So we have 4 terms. We can't do a greatest common factor out of all 4, so I'm going to use grouping. So I will first take out a negative 4x squared, and that'll give me x plus 2. I'll take out a positive 5. That'll give me x plus 2, which is good. So I've got x plus 2 as one of my factors, and then I've got negative 4x squared plus 5 equals 0. So what are these solutions? Well, I know this solution is x equals negative 2. This solution is going to be, I'm going to get negative 5 divided by negative 4. So I get x squared equals 5 over 4. And then when I take the square root of both sides, I'm going to get x equals plus or minus square root of 5 over 2, since the square root of 4 is 2. All right, so there are my solutions. Okay, number 17, evaluate the expression 9 to the 3 halves. Okay, so remember the denominator here basically acts like a root when we have a fractional exponent, and then the numerator acts as the power. So I'm going to do the root first. So 9, and then this is a square root, so the square root of 9. This is basically the square root of 9 to the third power. So that's going to be 3 to the third power, which is going to be 27. All right, number 18. I want to solve x minus 3 equals square root of x plus 9. So we're going to square both sides. But remember, when we square the left side, this is x minus 3 times x minus 3. That's not x squared minus 9. Then we have x plus 9 over there. So this is x squared minus 6x plus 9 equals x plus 9. So this is going to work out kind of nice when I subtract x and 9 from both sides. I will get x squared minus 7x, and then the 9's go away. So I get 0. So I have x and then x minus 7. So my two solutions are x equals 0 and x equals 7. And then I need to go ahead and check that these work. So what happens here is when I plug in 0, I get 0 minus 3, which is negative 3, and then I get the square root of 0 plus 9, which is 3. So that's not going to work. So 0 is extraneous. 7, I believe, is going to work. 7 minus 3, that's 4. And then square root of 7 plus 9, that's going to be square root of 16, which is 4. All right, so 7 is my solution. Number 19, determine if the function y equals 3e to the negative 2x represents exponential growth or exponential decay. Well, because this is a negative exponent, that's going to move it to the denominator, which means we're going to have exponential decay. All right, number 20, the inverse of the function. All right, so if we wanted to find the inverse, what we could do is we could swap the f of x and the x. So we'd have x is equal to the natural log of f of x, 3f of x, plus 1, or we could make that y, but I'll leave it as f of x. So then I want to take both sides and make e the base, so that'll cancel the natural log. So I'll have e to the x is equal to 3 times f, I guess I can call that f to the negative 1x, plus 1. Then I'm going to solve for the inverse. So I will subtract 1 and then divide by 3. So the inverse function is going to be e to the x minus 1 divided by 3. Cool. 21. So we want to solve the equation. So we're going to rewrite this logarithm as an exponential equation. So we're going to have 4 to the second power is equal to the 2x plus 2. So that is 16 equals 2x plus 2. Subtract 2, you get 14 equals 2x. And then you get x equals 7. We want to check that to make sure that works. So we get log base 4 of 2 times 7 plus 2. That's going to be 16 equals 2. So we have log base 4 of 16 equals 2. And yes, that's going to be true because 4 to the second power is 16. All right, we want to condense. So condense the logarithm. So every logarithm that's positive is going to be up top. These all have the same base. We're going to move all the numbers out front to the exponents. And then we'll see what happens to there. So we're going to have one logarithm. And it'll be, let's see, log of 4. So that's 4. We'll have a fraction. X squared. And then x to the third, because those are all the positive ones, right? Positive, 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 and then the negative ones will be 2 and y to the third. So if we simplified that, that's going to be log of 4x to the fifth over 2y to the third, and we can simplify the 4 over 2, so we got log of 2x to the fifth over y to the third. That's our final answer. All right, number 23. Getting there. Simplify the rational expression. Okay, so whenever we get something like this, we want to try to factor it first. So up top, can we factor it? I think so. We got x and x. 30, that's going to be 6 and 5. So we got plus 6 plus 5. Over the denominator, we're going to have x plus 6, x minus 6, since that is the difference of squares. We know that x plus 6 will simplify to 1. So we've got x plus 5 over x minus 6. Good deal. All right, so then we want to find the sum. So to find the sum, we need to see what this factors to. So this is an equation or expression we had earlier, x plus 9, x plus 7. So since they share the x plus 7s, all we have to do is multiply this one by x plus 9 in the numerator and denominator, and then we can combine them. So when we combine them, our denominator is just going to be x plus 9, x plus 7, because that's the common denominator. We're going to have 4 minus, and then we have to carry the minus through, so that's minus 4x minus 4 times 9, that's 36. So then we'll have 4 minus 36, that's negative 32 minus 4x over those two things, x plus 9, x plus 7. There we go. All right, number 25. What is the 20th term of the sequence 32, 22, 12, 2? So it looks like we are subtracting 10 each time. So we've got our sequence is going to be 32, the first term, minus 10 times n minus 1. So if we want the 20th term, we can do 32 minus 10 times 20 minus 1. So that's going to be 32 minus, that's 10 times 19, so 190. And let's see, that's going to be negative 152. Let's see, 32 minus 190, negative 158. All right, so that's the 20th term. Number 26. What is the 9th term of the sequence? 9, 18 times 2 times 2 times 2. So that's kind of nice. So we got a sub n is equal to 9 times 2 to the n minus 1. So if we want the 9th term, it's going to be 9 times 2 to the 8th power. That's 256 times 9, and that's going to be 2,304. All right, matrix. So if we want to find A plus B, these are two 4 by 3 matrices. So if we want to add them together, we're just going to have to make sure we add all these things up. So there we go. A times B. So we got a 3 by 2 and a 3 by 3, and a 3 by 2. So we can multiply these. This is going to be fun. All right, so if we multiply them, we're doing a row times the column. If we're doing this by hand, so this will be good. All right, so row times column. So we got 4 times -9, that's -36. -9 times 8, that is -72. 8 times -1, that is -8. So let's see, that'll be -108. That worked out nice. So there we go. There's our matrix multiplication. Area of a triangle with those vertices. So let's see, the area formula is going to be plus or minus 1/2 times the determinant of the point. So 3, 0, 1, -7, 4, 1, 3, 6, and 1. And we want to find the determinant. So to do that, we're going to bring out those first 2 columns, and we're going to multiply. So 12 minus 42, that's going to be -30, minus 12 and 18 is 30. So let's see, -30 minus 30 is -60. So we have 1/2 plus or minus times -60. We want to use the negative, so our area is going to be 30. There we go. Last question of the review. Last question for the final exam is going to be similar to this. So find the inverse of the matrix. Okay, so we want to find a to the -1, the inverse. So we're going to have to get the, well, let me just wait. We're going to get the determinant of this, and let's see. So we got -5 minus -24. So that's going to be -5 plus 24. That's going to be 19. All right, good deal. So we got 1/19 times, and we're going to rearrange this matrix. So we got -1 and 5 switch places. That's -8, +3. And now we just multiply. So the inverse matrix is going to be -1/19, -8/19, 3/19, and 5/19. Not too pretty, but that will be the inverse of the original matrix. So there you have it. There's your Algebra 2 final exam review. Covers pretty much everything. Again, if you need to look back at something, just feel free to go back into the question that you have. So thanks, everybody, and looking forward to your final exam. Make sure you study.